Yeah. And how do you set your students up so that they get in the habit of backing up their claims? Like when they're making an inference, what do you really want them to use as evidence for those inferences?
So the probability value, the p-value, is the classic, evidence that we provide.
Yeah.
As evidence against the null. So when I do my activities from day one with smelling Parkinson's or later in the year, a lot of them are simulations.
Yeah.
And so we make dot plots with stickers, and you can buy those at any office supply store.
Yeah.
And what I do is I have them use one color of dot and a second color, usually red, for the what would be the p-value. And so I try and tie all of that back together. We start, shading tails, even though they don't know that,
Right.
from day one. And so I guess I keep you keep feeding back into the question. The key question is, would this be reasonable to happen by chance?
Yeah.
And if you start with that, you can weave that in through the entire course. Would it be reasonable to happen by chance? Would it be reasonable to happen by chance?
Right.
And so that's the decision-making criterion. And as soon as you get to the point where you feel it'd be unreasonable, well, then that means some claim that we thought was true might not be true now.
Right. Right.
And so I think that's how you tie all of that together.
And I use that phrase, would it be reasonable for this to happen by chance? I use that often. And another activity that I do, just to get them thinking, is I got this from Roxy Peck, I just take a deck of cards, or a couple decks, and one deck is perfectly untouched, everything's fine with it. The other deck, I've taken and replaced all the black cards with red cards. So I've got to maybe leave a few black
You've
cards
got a
in there.
stacked deck.
I've got a stacked deck, exactly. And I just start flipping cards over and say, okay, what do you think? I'm asking you about the fairness of this deck of cards.
Yeah.
And then I shove it back in, reshuffle, pull another one.
Right. How long?
How many draws? How many reds in a row are you willing to accept before you start questioning the fairness?
Yeah. Yeah.
And 5 often comes up
5.
as a number in my class.
5. You get to about 5 and they start to freak out a little
Right.
bit.
Right. Right, right. But I think that those are the experience that we have to kind of shake, that when you look at different objects and you make assumptions, sometimes those assumptions may not be true. And there are times when you actually have to collect data on something to actually, from the data about whether or not something, if you think was fair, is it really fair?
Right.
And I think that really promotes the empirical approach. I also really liked what you were saying before about depends on how far along we've been on probability, and that with both of you taking a simulation approach to thinking about inferential reaning, at the core they are building probability models, and they have to be able to think about, if we're going to assume, could this happen by chance? Well, then what is the model? What's the chance model that we're assuming is true? And then building from that. And I also loved hearing that it seems like you're starting with these hands-on experiences and getting the students, experiences with that and collecting repeated samples. That the dot plot you were talking about is not just a dot plot of a single sample.
Right.
It's, each dot is representing a proportion or whatever statistic we're collecting, mean, from each sample. And it's an empirical sampling distribution.
Right.
Yeah. And
So I think, what do we want students to do? We want them to take these abstract concepts. Sampling distributions are the most abstract concept.
They are.
Who thinks about repeated sampling ever? No one. And in practice, we don't do that. If we can, we just take one single larger sample, right?
Right.
We don't take multiple smaller samples. So I think the best chance that students have to understand what's going on is to calculate the number themselves in as real and tangible a way, and then make a dot. And then those technologies that we talked about just build more dots for us.
Right.
And
but they have
so-
to understand what the dot means
Exactly.
at first.
And all the time when you make dot plots from the start of the course to the end, one of the key questions is, what does that dot represent?
Yeah.
Right?
They ask the same
Explain
question.
that dot to me. What is that all about?
Yeah.
And so I think technology, what it buys us is the chance to build empirical distributions quickly, but also for students to connect physical to technological representations.
Yeah. Yeah.
And so then maybe histograms and things like that that get spit out of software are a little less mysterious, right? They have more meaning attached to them.
Right, right.